In this video, I will show you how to debug the Internet Control Message Protocol known as ICMP and the Address Resolution Protocol known as ARP on the Nokia 7750 service router. We will test connectivity using the ping utility, pinging from one PE to the other and verifying the operations of ICMP ARP. The ping utility, which uses ICMP, is very useful for troubleshooting connectivity issues. It, however, does not provide us with detailed information about the issue. In other words, we don't know if the problem is with the source, the destination, or the link between the source and the destination. By using the debug utility, it is possible to narrow down the connectivity problem. To begin, we configure a log file that will receive the output from the debug trace and display this output to the CLI session. We then enable debug and define the desired information. In our case, it will be ICMP and ARP. So let's start off by creating the log file. We go to PE2, which is our destination PE, and we issue the configure log. So configure log ID to specify an ID for this log. As you can see, you can choose any number between 1 and 100. For our case, let's use 30. Hit return. We then need to specify that we want debug traces to be logged into this log file. To do that, we say from debug trace. We then need to specify where we want this to be output. In our case, we want it to be output to the session with the CLI session. So to do that, we issue the to session command and then exit. So if we then go ahead and start a debug to capture the ICMP packet, to do that, we issue the debug router IP. Before I carry on to type ICMP, I'm going to use the question mark to show you what other instances of debug you can capture here. You can capture ARP, which I'm going to do next, DHCP, DHCP6, event, ICMP, ICMP6, the interface, and as you can see, the routing table, tunnel table, etc. So let's complete this debug command by issuing the ICMP, which is what we want. So debug router IP ICMP. Debug is now running on PE2. That's confirmed by showing it. Show debug to confirm. So debug is running, IP capturing ICMP packets. We then go over to PE1, our source, and ping the interface IP address of PE2. So we do ping 10.10.10.2, hit return. We can see we're getting ICMP replies. PE1 has sent 5 query packets and has received 5 back from PE2. Let's go over to PE2 and see what ours captured. So as expected, the first packet is an ingressing packet from PE1. So it's saying I can see ICMP ingressing on my local interface called to PE1 from the IP address 10.10.10.1, and it's coming to my local IP address, local interface IP address of 10.10.10.2. So the next packet now is saying I am replying to that ping query. As you can see, ICMP egress. The first one is ingressing, which means coming in. The second one is egressing, which means going out on the same local interface to PE1, but this time around it's coming from my local IP address, my local interface IP address of 10.10.10.2, and it's going to PE1's local IP address as well on the same link. So you get that for every packet it received. That's why we've got 10 packets here. So what we're going to do next, we're going to try and break this, and by that we need to go back to PE1 and source this ping from the system interface IP address, which PE2 does not know about. So let's go and do that. We issue the same command, which is ping 10.10.10.2, but this time around we use the source IP address of the PE1 system interface, which is 1.1.1.1. This will fail. So PE1 will still send out 5 packets, 5 query ICMP packets. But this time around, PE2, on the other hand, does not know how to get to the 1.1.1 system interface on PE1. So let's confirm that anyway. So as you can see, the next 5 packets, which is from 11 to 15, is only saying I can see ICMP ingressing on my local interface to PE1 from an IP address of 1.1.1.1, and it's trying to get to my local interface IP address. I however don't know how to get to 1.1.1.1. So PE2 does not reply because it doesn't know how to get to 1.1.1.1. So we see the 5 query packets coming in from PE1, but we don't see any packets egressing back from PE2 to PE1. So let's now test for app. To do that, we need to first clear the app table. Let's see what's in that table before we clear it, and I'll explain a few things to you. So if we do show router app, from what we can see here, from the previous ping that we issued, the successful one from PE1, we can see that PE2 learned about PE1's IP address, and it has associated a MAC address to it. The timing for the MAC addresses to timeout from the app table is 4 hours by default. So you can see the local IP address of the system IP address of PE2 is not dynamic, it's static. It's got this 0th, and the interface is system, and then the local interface as well to PE1 is also not dynamic. It is a static entry. It's local entry, it does not time out. It's got the IP address of 10.10.10.2. However, this one from PE1 is dynamic. So let's clear that app table. Clear router app, I think we use all. So we clear the app table using that command, clear router app table, app all. Let's show the app table again just to make sure that we only have the local entries. Yes, so we only have the 2 local entries. So now let's go back. Before we do that, we need to change the debug from ICMP to app. So to do that, we need to issue the debug router IP no ICMP. It return that has now stopped the debug from capturing IP ICMP. We now have to tell the debug that we only want to capture app. To do that, we issue the debug router IP again, but this time we want app. It return. Now this PE2 is only debugging for IP app packets. So let's go back to PE1, which is our source, and issue the first successful ping, which is the one going to the local IP address, the adjacent IP address of PE2. It return, yes, we're going to get reply because PE1 knows how to get to PE2 on that local interface. What has the debug on PE2 done? Good. So we see the first instance 1. It has definitely seen that packet, that app packet saying who is 10.10.10.1, tell 10.10.10.2. So it's learned about that IP address and it has put it into the app table. It has also associated the MAC address, which is what we had before. If you look at this MAC address here, you'll see that it was the same. It is the same thing as we learned earlier. So it has associated that MAC address to the IP address, the interface IP address of PE1, and it has definitely put it into the app table again. So as you can see, it's now back into the app table. But what we're going to do again, we're going to now clear the app table one more time. Show router app. just to make sure it's now cleared. It is cleared. But now again, we're going to try and ping PE2, sourcing it from the PE1's system interface IP address. As you remember, PE2 does not know how to get to the system interface IP address of PE1. So we are expecting this to fail as well. So let's issue the same command, ping 10.10.10.2, and we source it from the PE1's system IP, system interface IP. Hit return. This is going to fail. PE1 is still going to issue the 5 ICMP query packets as per normal, but this time around on PE2 we see absolutely nothing up. Yeah, nothing is sent. App does not get through. We can check again the app table. Nothing is learned in the app table. This is because PE1 cannot associate that IP address to an interface, and it cannot associate the 1.1.1.1. It doesn't know where that is coming from. It doesn't know what interface to associate it with. It doesn't know what MAC address to put against this IP address. In that essence, it does not do anything. It leaves it blank because it's saying, I don't know how to get to the IP. I'm not going to do anything. It could be a rogue IP. I'm not going to do anything about it. I'm not going to put it into my app table. Simple as that. So as you can see, the debug command can be very useful. We're going to use this quite a lot in the upcoming videos. So don't worry. For now, just try and digest what we've just done. This concludes this video. I hope you find this very useful. If you do, kindly give this video a like, and please don't forget to subscribe. Thank you for watching.